Let's just jump right in, shall we? Today's explainer is taking us straight to the moon to unpack the incredibly dramatic yet wildly successful reality of India's Chandrayaan-2 mission. Seriously, this is a story packed with massive ambition, some truly heartbreaking setbacks, and a scientific legacy that is literally rewriting our understanding of the solar system as we speak. So, if you're here to cut through the noise and get straight to the facts, you're absolutely in the right place. Here is a quick look at our flight plan today. We'll be covering 1. Ambition and independence. 2. The 3 spacecraft. 3. The journey and crash. 4. The orbiter's triumphant survival. And finally, 5. Groundbreaking lunar science. Let's get to it. Section 1. Ambition and independence. To really grasp the scale of Chandrayaan-2, we've got to look at its origins and India's seriously bold objective to explore the completely uncharted territory of the lunar South Pole. What's wild is how this whole thing evolved from a stalled international partnership into this massive display of national self-reliance. You see, back in 2007, the Indian Space Research Organization, or ISRO, and Russia's Roscosmos actually signed an agreement to work together. The plan was for Russia to provide the lander. But by 2013, that Russian lander was facing heavy delays after some issues with their own Mars mission. So what did India do? Well, by 2015, they made the incredibly courageous decision to just go it alone. They went completely independent, redesigned the mission to build the whole shebang themselves, and that culminated in the historic 2019 launch. And that commitment, it did not come cheap. We're talking a massive 9.78 billion Indian rupees, which was roughly 141 million US dollars at the time. This huge financial figure really highlights the high stakes of going independent. India wasn't just throwing a standard satellite into orbit. They were taking on one of the absolute most difficult engineering feats in human history. Moving on to Section 2, the 3 spacecraft. Let's meet the explorers, the 3 distinct mechanical characters that actually made up this incredibly complex, multi-layered mission. Looking at the stats here, there's a very clear division of labor between these 3. Up top, we have the heavy lifter, the orbiter. This thing weighs in at nearly 2,400 kilograms and pumps out a massive 1,000 watts of power to run its suite of heavy scientific instruments. Then we have the Vikram lander. Coming in at 1,471 kilograms, it's a highly specialized descent vehicle named after the founder of the Indian space program, and it was designed specifically to navigate that harsh, unforgiving lunar descent. And finally, tucked right inside Vikram was the Pragyan rover. This was a tiny 27-kilogram robotic scientist running on just 50 watts of power, built to literally roll out and leave India's mark right on the lunar surface. Section 3. The journey and crash. This is where we get into the most dramatic phase of the mission, where immense mathematical precision meets the harsh, unforgiving reality of space. Now, lunar travel requires agonizing patience. After a picture-perfect launch on July 22, 2019, the spacecraft spent weeks just gradually raising its Earth orbit before finally slingshotting toward the moon on August 14th. By August 20th, it successfully inserted itself right into lunar orbit. The suspense was absolutely building worldwide as they approached that fateful September 6th landing attempt near the moon's south pole. So the Vikram lander detached and began its autonomous descent. And, everything was functioning perfectly, right up until the craft reached an altitude of just 2.1 kilometers. But at that exact critical moment, a software glitch caused the lander to deviate from its trajectory. It just couldn't correct itself in time, and that led to a hard crash landing. The control room went completely silent, leaving us with this devastating official update. Communication with lander and ground station was lost. Which naturally leads me to ask you this absolutely crucial question. Did the mission actually fail? Because of all the intense media focus on the crash, this is a super common misconception. But as we're about to see, losing the lander was only a fraction of the total story. Section 4, the orbiter's triumphant survival. Because out of that devastating silence emerged an unbelievable scientific redemption arc. Check this out. While the Vikram lander unfortunately achieved 0 days of its planned 14-day surface mission, the orbiter remained completely healthy, hanging out 100 kilometers above the moon. And get this, because the launch was so highly precise, it saved a massive amount of fuel. That meant the orbiter's lifespan was extended from an expected 1 year to a staggering 7.5 years. The heavy lifter survived. To put the power of this surviving orbiter into perspective, just look at its extreme resolution, 0.32 meters. The Orbiter high-resolution camera can literally spot objects on the moon's surface as small as 32 centimeters across. That officially makes it the sharpest camera of any lunar orbiter mission in history. Pretty incredible, right? Section 5. Groundbreaking Lunar Science. So, what exactly is the orbiter doing with all that power? Let's dive into the amazing stream of data that is pouring back to Earth as we speak. The orbiter is carrying a payload of 8 advanced instruments, and they are actively rewriting our understanding of both the moon and our sun. We're talking finding noble gases in totally unexpected places, discovering dynamic geological features, analyzing solar flares, and even deploying dual-frequency radar to hunt for water ice in permanently shadowed craters. Let's actually break a few of these major findings down. To really get our first major finding, we have to talk about the exosphere. Now, the moon doesn't have a thick atmosphere like Earth does, but it does have this extremely tenuous outermost region. The molecules there are gravitationally bound to the moon, but they are so spread out that they rarely even collide. Well, right inside this exosphere, an instrument called CHASE-2 detected the noble gas argon-40. And why is this such a big deal? Previously, we had mostly just found this gas near the moon's equator, but the orbiter went ahead and mapped argon-40 over the South Pole Aten terrain and mid-latitude regions for the very first time. Since argon-40 actually comes from radioactive decay beneath the surface, finding it in these new spots literally forces scientists to completely rethink how the lunar surface interacts with its exosphere. Okay, next up, let's talk lunar geology. You might be surprised to hear about Lobot scarps. These are relatively small-scale tectonic landforms that basically act as the surface expression of low-angle thrust faults. To put it simply, they're like wrinkles on the moon's surface, and they're caused by the moon shrinking as its interior cools down. The absolute crucial takeaway here is that the moon is not completely geologically dead. Using its terrain mapping camera, or TMC-2, the orbiter managed to map a massive 1,416-meter-long lobate scarp. And because the orbiter can capture these images at low sun elevation angles, it creates these long shadows that make these tiny geological features just pop right out. It completely proves the orbiter's immense, ongoing value to geologists who are trying to map these shockingly young tectonic shifts. But interestingly, Chandrayaan-2 isn't just looking down at the moon, it's also looking out. By using its solar X-ray monitor, the orbiter actually tracked B-class solar flares coming from our sun. Scientists were able to observe this fascinating two-step process. Step 1, during the peak of the solar flare, the abundance of elements like magnesium, aluminum, silicon, and sulfur actually decreases. Then, step 2, as the flare decays, those elemental abundances rapidly return right back to their pre-flare levels. This is an unprecedented observation of absolute abundances during microflares, and it was captured all the way from lunar orbit. And that brings us to the end of today's explainer, but I want to leave you with this final provocative thought. If a so-called failed mission, one that tragically lost its lander, can still manage to redefine our understanding of the lunar exosphere, lunar geology, and even the solar flares of our own sun, what other secrets is this orbiter going to uncover next in its massive 7.5-year lifespan? The resilience of science is just truly fascinating. Thank you so much for joining me today. Keep learning, keep questioning, and we'll see you next time.